Welcome everyone to the SNIA Network Storage Forum, Why Web 3.0 is Important to Enterprise Storage. Today we're going to have several presenters talk about this interesting topic. The first one is Stefaan Vervaet, and he's the head of network growth for Filecoin, where he's responsible for growing the storage provider and client ecosystem. Filecoin is a global storage network with the mission of creating decentralized, efficient, and robust foundation for humanity's information. He's also the leader at Protocol Labs, a research, development, and deployment institution for network protocols. Stefaan has 20 years of product and marketing infrastructure experience in the enterprise space, and he successfully helped build multiple startups in the distributed storage and private cloud space, holding a master's degree from the University of Ghent. Our second presenter is going to be Rafal Szczesniak, and he's a senior principal software engineer working on network protocols, distributed scale-out NAS at Dell Technologies, with 2 decades of experience in traditional storage. As part of his SNIA activities, Rafal is engaged in promoting blockchain storage projects within SNIA and facilitating development and developing interoperability standards and cross-pollination between blockchain storage ecosystem and the enterprise storage ecosystem. And then finally, Shawn Flynn leverages his extensive global background in various business stages and industries in his position as principal at a leading middle market investment bank, where he specializes in mergers and acquisitions, securing growth in capital and secondaries. He's the well-known and respected host of the award-winning podcast, the Silicon Valley Podcast. So after topic introductions from Stefaan and Rafal, Shawn will be posing questions to them during our discussion section. So first, let's talk about a little bit about SNIA. So SNIA is a very large global organization with 180 member companies and 2,500 active members and 50,000 end users and storage professionals worldwide. We cover a variety of topics, including traditional networking and storage networking protocols, storage architectures and cloud storage, the protocols that go with that. How do you secure the whole thing? How do you deal with long-term data? And we're moving into sort of the convergence of compute memory and storage more and more as the industry evolves. This is the standard legal disclaimer that says no warranty is expressed or implied, use at your own risk. And all this material has a dual copyright between SNIA and the owners. And then our agenda today, we're going to talk about centralized versus decentralized services, storage and Web 3.0, and then the panel discussion. So with that, I will turn it over to Rafal.
Thank you, Joe. Hello, everyone. This is Rafal. Before we discuss this storage aspect of Web3, which is the main thing that we'd like to discuss, let's briefly compare traditional services with decentralized services so that we have a little bit better understanding of the level of distribution and the role that blockchain is playing. So with centralized services, we've got usual client-server connections. These days, within enterprise services, there's way more than just one server. There are multiple endpoints that you can connect to. Those servers, sooner or later, when they interact with the client, are going to use storage. It may be distributed traditional scale-out storage. It may be one single server. It may be a cloud storage as well. Still, this is within the hands of usually one or maybe few vendors. However, as a client, when we connect, we typically interact with just one vendor. So the server side of the application, the web application that we access, is controlled by one vendor. That vendor needs to be trusted. We need an account usually to connect to those services, and it can fail, even though there may be many endpoints, there may be many data centers. Infrastructure sometimes fails, and that's beyond the control of individual vendors. Accidents happen, and with that, it may happen that we are under attack. Joe. Yep, those slides are back. Okay, thank you. So how does this look when compared to decentralized services? With decentralized services, we've got a network running blockchain. And for the sake of simplicity, let's assume those are just full nodes that contain the entire database of all blockchain records. They are distributed, decentralized across many geographical locations. It's a huge network. So the probability that we're going to have a failure, infrastructure failure, is very, very low. It's virtually impossible because you would have to take down the whole network. Every single one of those nodes, again, let's assume those are identical full nodes. Every one of those nodes is running the same application layer, the same blockchain. So no matter where we connect, they're going to respond the same way and communicate and distribute the communication between them. Client, in order to use those services, need client to use front-end or interface. It can be a traditional web service, for instance, allowing access to distributed service, decentralized service. It can also be something that you run locally on your client and just access it through local hosts and through the web browser, for instance. So when the interaction occurs between the client and the decentralized service, the action happens on a blockchain through a smart contract, one or maybe more of them. There are distributed applications that running many smart contracts. Everything is recorded on blockchain, and the response comes back to the interface and come back to the client. Just like with centralized traditional services, sooner or later we may need to use storage. And front-end, yes, it can use existing cloud services, for instance, for storing the data, but it can also use storage network. And the reason why you don't want to use blockchain for that, the blockchain that runs your smart contracts, is because every single operation and placing every single piece of data on a blockchain is really expensive. If you have vast amounts of data to store on blockchain, this is going to be prohibitively expensive. So we want to use a different network specialized in data storage for the purpose of storing, for instance, images, text documents, things like that. So with the key difference when compared to centralized services is that there is no single vendor controlling the application. It's a smart contract deployed on the blockchain, and the code is the law. So there is no chance that one vendor would like to just shut down the service and the application and it's no longer accessible. That's not possible. With highly decentralized network of nodes, meaning many hundreds, thousands maybe of nodes distributed across the globe, this means we've got high resiliency of the service. Like I said, the chances that the network will go down are very, very low. Application state, and by application state I mean the data recorded by smart contracts is recorded immutably on the blockchain, because that's the nature of blockchain. That's one of the fundamental features of blockchain. So the whole history is there, and if we run an application that requires recording certain critical things for instance, for security or for proofs of anything, then blockchain is ideal for that. With blockchain network, we do not need to trust anyone, so we do not need any account. We just need access to the network and certain amount of tokens that run the network to use it to pay for the transactions, for sending anything through the smart contracts, and that's it. And finally, users of the blockchain can interact with each other without any middleman. Like I said, there is no vendor control, so there are consumers, there are producers. They can meet on the blockchain and interact with each other. So this builds a community. When it comes to storage, which is something that's of interest, if you think of existing distributed decentralized storage networks like peer-to-peer, IPFS will be a good example. You can save data in such a network. You can retrieve data pretty much from any node that is available, assuming the node, of course, has the data, and which means the lookup of the data lookup and retrieving the data is based on a goodwill. Actually, the data has to be there. With blockchain, if we add blockchain to the peer-to-peer network, then we build a layer of incentive. Storage nodes can offer space to rent for a certain amount of time, certain amount of space. Clients can request that space, and the transaction can occur on blockchain. Space offered is going to be rented, and the client happily saves the data in the network thanks to that offer. It's possible because for instance, in IPFS, and Stefan's going to cover that in more detail, the files are addressable through content addressing. Yeah, content addressing. It's a cryptographic hash of the data. So if you combine the hash with the transactions on the blockchain, then it's possible to prove that you store the data. And if you don't, then, well, you may be facing penalties. So there's both incentive to be fair, and there's also the potential penalty if you don't meet your end of the deal. So the key feature of blockchain storage network is, again, because it's a blockchain, no single vendor can control the storage. We do not need to trust anyone because it's recorded on blockchain. Interestingly, anyone can store in the network, and anyone can participate. So we do not need account in order to request the space to save our data, to store it. But we can also offer space for rent if we are running a business, or for instance, just to offset our costs. So with this introduction of the high-level, overview of what the blockchain storage networks are. Now let's dive a little bit deeper. Over to you, Stefan.
There we go. Can you hear me? All right. Thanks, everyone. My name is Stefan. I'm a community member here at Protocol Labs, focused on decentralization. One of the products we help as a community member, because we are one of thousand community members, is to help bring decentralized storage to the enterprise. And so if you look at Web3, as Rafal already mentioned, there's this new wave of Web3. It's focused on no centralization, essentially, right? No single entity, as Rafal mentioned, owns the physical assets or control over the software on how the software is run. All of that is community built, which means that this is not only an open source stack, but also decisions on how this source code is changed is community based. And the infrastructure is run by a community of thousands of servers, sometimes around the world, that are collaborating to build almost like a community cloud. It's user control. The focus is on user control data. So today, when you're signing up for Facebook or Instagram, you're essentially a product because you're not really paying for any services because you're sharing your data. So imagine a world where you have control over data. You can earn royalties over your data. Let's say you can go to a doctor and you can take your medical records with you and you control that. That's essentially where this Web3 wave is getting to. Like creators can own their own data and so on. And code is law. What that means is that it's the protocol that's running, the open source stack that's running, that decides how the community can behave, and that also allows what Rafal was referring to, a permissionless infrastructure, meaning anyone can join that network as long as they adhere to the protocol implementation. Moving to the next, what I want to do is the next couple of slides, because we can have multiple deep dive sessions after this initial session of today. But as you can see, we've kind of transitioned from kind of siloed storage with direct attached storage in the 50s, when the first hard drive, and then in 1983 when SMB implementation came out, all the way to today, to decentralized. And in between, we moved sort of like to a distributed architecture and federated architecture, and moved from enterprise to public, but not decentralized. And now we're in a situation where more decentralization is not only demanded from consumers and customers as sort of a right and a way to control their data, but also new applications are coming to life. And definitely now with this new AI wave, more and more people are looking to identify, control, and monetize their data sets. So Web3 storage, if we zoom in on the storage side and the compute side, because we're not just storing this data to preserve, but also storing it because eventually you want to compute and we want to drive value and monetize it. For Web3 storage to become accessible in the enterprise, we have to make it web scale. And so that is like where we are today. So you're seeing, I'll share a couple of solutions, but it's still in its infancy, and it's moving into enterprise sort of like in the same way as back in the day object storage was adopted, right? The early adopters were in research, universities, and then eventually media and entertainment, government came later, and then eventually enterprise came all the way at the end. So today you'll see there's some research institutes already using this technology because they truly value their data. They understand the value of immutability and so on. And I'll give you some examples at the end. But before we can zoom into some of the decentralized storage stacks, we have to talk about how the community had to fix the data accessibility issues that exist today, or that still exist today with HTTP. And so, as you can see today, data is sort of like censored in certain locations. Data is siloed behind firewalls or siloed architectures that don't allow you to actually use that data widely and easily. And what researchers are complaining, and not just to research institutes, is that links are breaking, meaning, you're pointing to a research paper and let's say the researcher stops paying their Amazon bill, then eventually that link can be broken. And, you have to find a way to address essentially these data sets in a different way than just using the HTTP or host name and IP address that you would normally use. And so, and then, of course, in emerging countries where there is no infrastructure, you have an opportunity to build something from scratch. And so, with IPFS being now like multiple years in the open source community and have adopted, IPFS has been adopted by tens of thousands of developers in the open source community, and definitely in Web3 has become the standard of how to address data. And that's primarily because it has allowed us to sort of like go towards a peer-to-peer interaction between two entities worldwide, and created a sort of a standard of how to address data in an easy and understandable way. But the way it works is very simple. It's using cryptographic hashes, as what Rafal was saying, to replace the HTTP and the location of the file with a hash. So instead of using an HTTP example.com, you will be using an actual hash. And what we have globally, or we, the community, it's not us, the community, because we don't run any of these nodes. They have the community is running a distributed hashing table that allows you to check where the actual location is stored of that data. So if let's say you want to pull up this DNS/example.com foobar bas, the PNG, you would actually use this hash, go to go to one of the index nodes, the DHT table, sorry, and you'll be able to fetch the file through its content addressable hash without really needing to know where that file is actually located. And that file can then be indexed around the world through IPFS nodes that could even pin a cached version for fast retrieval. And so this technology has been widely adopted now by a ton of Web3 developers worldwide, and also Web2 or Web 2.5 software systems that are trying to build this bridge between what we know of, as today Web 2 to sort of a decentralized stack of some sort that supports, the immutability and these smart contract capabilities. So at IPFS, it's an open source stack, and it sort of allowed these dApps, these application developers, to communicate peer-to-peer. The second thing the community had to solve for was to bring the community together, right? So one is like how we address data is completely done in a different way, but two, how do we bring, thousands of businesses, storage providers, as some decentralized networks call them, together to collaborate in the same way. So you, as a user that's storing data on these decentralized stacks, can be guaranteed that data is stored safely, in a consistent way, is addressed in a certain way, and so on. And so this is where blockchain and crypto comes into play, right? Because what are crypto or blockchain stacks actually doing? They're building a marketplace, and those are what we call them market protocols sometimes, but they're programmable value-creating networks with economic structure and incentives that are aligned to reach a similar vision, a similar outcome. And in storage, this would be, an example of that would be to ensure that data is protected in a similar way, that data is replicated in a similar way, and that integrity is kept intact. And so, when we look at some of these blockchain stacks that are coming out, they typically come out with a white paper. In the white paper, there is a clear description of how incentives are being built, who's getting incentivized for doing exactly what, and then that's written into the protocol, and that is the code, and the protocol is law, or code is law, and once it's running, it's actually actively executing on these incentives and also the penalties that come with it. And I think it's important before we go in a little bit more detail to highlight that, because I get this question a lot. What are sort of these crypto tokens providing to the end user? Because crypto is sort of typically referred to as cryptocurrency, but that doesn't really reflect what we're doing when it comes to infrastructure. And it's not really short crypto in general for cryptocurrency, but it's instead short for cryptography, right? And so in cryptography, as we all know, has two critical features. One, it's to authenticate that someone has or is who they are, or says who they are, and claims, and is who they claim to be, sorry. And also second, to protect the data or protect the user and ensure that the data is well protected. And so these decentralized storage stacks are using cryptography as a way to ensure that one, data is protected safely, two, integrity is maintained, and then on top of that, you can start to see new decentralized layers that either do key management or kind of replace the traditional Active Directory access control, essentially, right, capabilities. And there's a ton of new technologies that are being built now on top of these decentralized storage stacks that sort of replace what we know today in a traditional storage system layout that we can go deeper into in the next couple of series. But essentially, what we're trying to explain is that in a lot of ways, cryptocurrencies are referred to as crypto tokens that are used for payments and and used by applications. But when it comes to storage, it's really used as a utility token. It's really to enable that transaction, that peer-to-peer transaction between the user and the provider, or between the application developer that's building on top of decentralized storage stacks and is, transacting directly with a community member that's providing storage infrastructure and, agrees to support and store this data with a certain SLA. And there's a ton of details, but in general, the benefits of decentralized storage that are enabled by blockchain are, one, it's more cost optimized, because now and it's a percentage of the cost of public cloud at this point, because the supply in certain blockchain or in certain decentralized storage networks is so much higher than the storage utilized. So, in general, there's an open marketplace, which means there's a lot more competition for your data sets. Second, there's a proof of daily integrity verification done. Now that you have these cryptographic hashes, and as what Rafal was saying, is you wouldn't store the actual data on chain. What you would be storing is those cryptographic hashes on chain that represent the original data. And then you can do a ton of verification. You can actually verify them as well. You can use those verification checksums to verify if the data is still the same, because with those cryptographic hashes, one, the benefit is that you have a unique identifier globally across the world that you can use to address, track, and index the file. And two, you can use that to verify if the content of the file wasn't changed. So now integrity and demonstrating that the file is authentic is a lot easier, because it sort of comes naturally into the stack. And why is that possible? It's possible because you have these advanced cryptographic hashes, and you're doing you're using content addressable storage. Second, data is stored immutable. And the benefit of decentralization is that there is no central entity that has full control to overwrite your data, right? So that's sort of like native. It is a benefit. Yeah, and I see here thank you for pointing this out. There is a mistake here in this slide. It should say chain of custody. And then so the outcome of that is that you have provable storage. So you have the ability to prove that, one, the data is the original. Two, you can prove where it's stored, when it was verified, and who eventually owns that data, and trace the flow of data over time. And then last but not least, smart contracts. We kind of touched on it. So there's a lot of things you can do now once that data is stored on a decentralized stack, right? Because now you can start building DAOs, data DAOs, and again, there's a whole other segment, but it's where people come together, communities come together to fund certain data sets, and that becomes a decentralized autonomous organization. That's what DAO stands for. But then let's say apply to a data set. And so we're seeing a ton of interest in that. And it's very exciting now that with this new AI wave, sort of a lot more people are starting to think about, how do I organize, fund, and monetize, right, my data sets? And this is an infrastructure that could offer that. When you look at the landscape, I have a couple more minutes left. There's a few networks out there today. Again, in different sizes, Filecoin, Arweave, Storj, and they have different benefits. They have different approaches, different sizes. In the end, I recommend to go to blockcrunch.substack.com. Here's a link where you can see it. And I can obviously, I have more details on Filecoin just because of the background that I have. But all of them have their own benefits. They have their own strategies. Some of them are more product oriented in the sense that they deliver more of an end product experience, where others are more focused on building a more decentralized platform where other solutions can be built on top of it. So we can do a more deep dive. But what's important here is that there's in general very similar ways to get to a certain outcome. And some of them are more a combination. As you look at these networks, Filecoin is sort of a proof of replication, proof of space-time, where SNIA uses Merkle proofs, and Arweave uses a smart weave, and Storj uses Merkle proofs. So all of them are using some form of cryptography, and of course, blockchain-enabled stack. But in general, we're indexing data on a different in a different way than you would index data or store data today in a traditional object stored. But if you look at how data gets onboarded to these networks, you will still see sort of these gateways that are translating from S3 type of interfaces to the custom proprietary interface on the back end that is managed by these decentralized stacks. There's some more detail here, like features. Again, in the interest of time, maybe we can address some of it in the panel, or if there's any questions in the chat, please let me know. But let me go deeper in Filecoin. I'll share a couple of case studies and also benefits. Just because this is an open source stack, it's running in the field, is the largest out there, has 12 exabytes of capacity. And so some of the benefits here is that we have thousands of storage providers in this ecosystem that are incentivized to provide a high quality of service. And the way that happens is that in the protocol, in the code, right, upfront, there was a pledge requirement, which is a requirement of these providers to put Filecoin in a wallet that can be used by the protocol and will be used by the protocol if the storage provider does not keep those servers up and running 24/7, and if the storage providers cannot guarantee integrity, meaning they cannot verify on a daily basis that that data is still exactly the same data that was originally stored. And so that reinforces data integrity, that enforces a certain SLA and quality, plus it allows for anyone to participate in this network without having a central certification or agency or agent that sits in between that sort of like enforces certain quality, because the actual algorithm itself, the protocol itself, sort of like requires and guarantees that. So when it comes to integrity, kind of referred to it before, but Filecoin in particular is using a proof of space. We call it, Filecoin calls it proof of space, but the process it's using underneath is essentially it's chunking the file in smaller segments of 32 gig. If you're storing smaller files, it sort of aggregates them. And then the storage providers are held accountable to prove on a daily basis that, through running these hashes, that the hashes are still exactly the same as the hashes that were stored on the blockchain. And if they can demonstrate that, then there is no penalty. But if, let's say, the data is gone or the data was corrupted, then that hash will be different and the provider will be slashed. So here as well, like this is all happening in code, it's running, it's out there. And so you either choose to adhere to the code, or you don't participate. The steps to onboard in Filecoin's example is, as a client, an enterprise or consumer, you can negotiate directly with any of these providers in your own region, and then you can provide the data. There's a process, of course. This is not, you can't just store that data directly into its native format into this stack. So those are sort of like the unique characteristics, is that you have to onboard that data in a specific format, which in the case of Filecoin, it's called a car file. And that is a very specific file that indexes the data in a certain way and ensures there's hashes being calculated that are then used eventually in the back end by these providers to verify that the integrity is still intact. So after onboarding the data, the integrity starts, and these SPs are required to provide integrity checksums. I wanted to share a couple of examples. As I mentioned in the beginning, again, we're seeing sort of like the similar trend. We're seeing like a similar adoption behavior as we saw 16, 17 years ago when some of the cloud providers came out with object interfaces. And you can see that, the researcher community, is already sort of like a unique persona in the sense that they're already pushing the boundaries. They're, disruptors in nature. And so they're also typically people that really value their data sets. They understand that the importance of data as a whole. They're typically doing machine learning in some form or way, or doing analysis. And so they understand that over time, these assets could actually become more valuable. And so, and also the retention of data is typically a lot longer. So here's an example of Atlas, the Atlas project at CERN that's storing more than 10 petabytes. I mean, today it's already grown larger on Filecoin, and it came from data that's stored on tape. They were very interested and are interested in the immutability, the geo-replication, all the attributes that come by default into decentralized network. Two is the University of Utah storing NASA atmospheric wind velocity and ocean data sets. These are public data sets. Again, started off with 200 terabytes. As you can see here, we're talking about petabytes. Considering the network today has, I think, 12 exabytes in capacity. More than 1 exabyte of data has been stored on Filecoin network today. So very active community, and these storage providers are actively pursuing customers, bringing deals onto the network because they act as service providers in this case for Web3 and Web2 use cases. Here as well, main value prop here is not just the immutability, but the ability to make this data available to the rest of the scientific community. As with in 2023, this is the year of science, or open science, I should say, where definitely in the US, there are more requirements when a scientist receives a grant. And so one of those requirements is that they need to have a data management strategy in place to make this the outcome, the results that come out of that project that was funded by the grant. They have to make that available. I think it's within 2 years time frame, and they have to demonstrate data management strategy. And so this is where decentralized storage stacks can come into play, because right now it's super cheap to store data on these decentralized stacks. So as you can see, research community is quite active in adopting this new technology. Another one which I thought was interesting is definitely with what's happening in the world today. Unfortunately, with the wars happening, making sure that the Holocaust testimonials and also what's happening in Ukraine. Actually, there are Ukrainian war testimonials and being stored on some of these decentralized stacks because, again, we want to make sure that data gets preserved and the authentic, right? The fact that data is being captured at the endpoints and cryptographic hashes can be actually captured at the endpoints as well, meaning at the location where the copy or the picture was taken. That can all be captured directly at the endpoint and ingested into a decentralized stack in such a way that we can trace and track, where the data was captured and ensure that it's that's stored in an immutable way, and there's no central entity that really controls and can remove that data. So here we are. This is a short overview. And last but not least, but we're also working on a decentralized storage alliance. So we're bringing vendors together from like Seagate, ENY, AMD to bring some of these newer architectures to the enterprise market. Sorry for taking so much time, but I hope this was helpful. Let's move over to the panel discussion.
Yeah, so Shawn, take it away for us. And we also have a couple of audience questions that will intersperse in there.
Fantastic. Can everyone hear me?
You're coming through.
Okay.
Perfect. All right. Some of these questions, yes, they were covered during the presentations, but let's dive right into it. So first question I have for Rafal. What is decentralized storage and how does it differ from centralized storage?
Well, it's decentralized. The key difference is that instead of even a large distributed network of nodes storing data in a way controlled by one single vendor, like it is the case with cloud storage these days, you've got the network of nodes ruled by the blockchain, which are not controlled by any single vendor. Anyone can participate. Anyone can join the network and offer space for storage. And the only rules that enforce are in the code, which is open source. Therefore, it's a community builder. So there is no middleman controlling that. And as we know, and as we've seen over the years, sometimes large corporations cannot be trusted. And not just because they are evil, but they're imperfect. So they may have their problems. So and it's with decentralized network, it's virtually impossible to just bring down the entire network.
Well, then, Rafal, dive a little bit deeper there. Between Web3 and Web2 technologies, how does that decentralized storage support that trust and control, or in contrast to Web 2.0?
With Web 2.0, yeah.
Oh,
okay. I thought you would.
Rafal, please continue.
Mm-hmm. With Web 2.0, which is where we are right now, again, you've got this entity that you need to trust. You need an account to log in. If you use services, sooner or later, there's going to be credit card number exchanged. And with Web 3, no need for an account. The only thing that you're going to need is your own cryptographic key in order to submit certain transactions. You may need, for specific kinds of networks, you may need cryptographic tokens. Yes, those you can purchase. But then you do not have to register. You do not have to pass your own personal information in order to access the service. And then, besides storage aspect of it, if you use decentralized application and you use smart contracts, then you can interact directly with whoever is offering you the service. So if you compare that to, for instance, like any online auction service where you have a service provider that coordinates your interaction with whomever you're going to purchase something from. There is no online platform for that. There is no corporation, there is no company running that and responsible for your personal information, for instance, and handling those transactions. This is all between you and the provider of whatever you want, and all the transactions are recorded on the network and on the blockchain. And it's given that it's immutable blockchain. Everything's recorded, everything's stored. So, for instance, if you imagine messaging protocols, then if you record something like that on the blockchain, then in the future there is no denial. Oh, I did not say that. That's just another example.
Okay, Stefan, do you want to elaborate on that before going to the next question?
Yeah, absolutely. So there's a lot more to it. Like there's different layers. There's a whole wave of zero knowledge proofs technology that's coming out, and it's not just coming out; it's being implemented in decentralized applications. What that means is that we now have technology that allows you to share you can share the outcome of a certain process, let's say, without sharing the actual inputs for that. And so what that allows, certain companies to do is like to share information amongst each other without sharing their actual costs or their IP. And so in the supply chain industry, ZK Proofs is now being deployed successfully, and it's been for a couple of years. Definitely those that have like understood the benefits of technology, because you don't have to have very extensive like integrations. You can just use these zero knowledge proofs, and they're secure enough to do peer-to-peer transactions, meaning sharing information without really sharing your costs, your margin, your IP, and still like guaranteeing that, let's say, a certain product has been manufactured in a certain way. Now, why do I bring this up? Because it's easy to understand how ZK proofs can be applied in a supply chain industry where you have different vendors interacting with each other, and they have to demonstrate that they have followed certain certifications and so on. Now apply this to data. Now apply this to the applications as we know today. This is what's happening. The traditional applications in Web 2 are being completely rewritten in a decentralized way, and all the layers as we know today, whether it's like I mentioned, a key management system, right? Right now that's centralized, or you need a certificate. Imagine that's decentralized as well as a layer that sits sort of like on top of a decentralized storage stack. In the same way, these zero knowledge proofs allow us to transact with other parties in a safe way without sharing our personal information, as what Rafal was saying. And the way we interact is with a wallet, and the wallet, maintains essentially, that's where your keys are stored. And so the whole notion of you signing up to a central system that someone owns and can be hacked and can be like, where your data can be read is now completely out of the picture. So imagine that you control your assets. Now, of course, you need to understand how to use a wallet, but that's all getting simplified. I mean, there's a ton of technologies like optimizing that. But imagine a world, and by the way, I can bring up multiple examples of applications in Web 2 today that are already using those technologies. They're just not as known yet because it hasn't reached enterprise or the consumers as we know today. But imagine that is all being disrupted right now. It's been happening for a couple of years. I mean, I've talked to startups that are building the next Spotify. They're not building it, they have it, right? Where creators like musicians don't have to give up 80% of their royalties to Spotify.
Yeah, they can just publish.
Exactly. They can just like focus. And also they can start to build incentives for their followers, right? They have full control of like, who do I want to give more awards? Those that are following me, in the early days, they're sort of like, they've kind of gone with me, right? They were with me in the early days. I'm going to give them more. Or, you can kind of incentivize other fans. I mean, this is just an example, right? It happens in the creative world because that's where sort of like, they're feeling the most pain. And those are also, in general, the first adopters of new technologies because they want to do something different. They understand that, what they're creating is super valuable,
I think I've actually heard
Streaming,
that
gaming.
startup. Yeah, the founder's not named Ivan, is it?
No.
Oh,
but there's multiple actually that are building.
There's many of them.
Yeah, and then you have a whole metaverse ecosystem as well.
Oh.
And you have gaming. You have it's very interesting. Once you have you understand the infrastructure, and you can start and you can control the data. You can can drive more value out of it.
Well, question with that. I mean, and maybe Rafal, maybe you want to take this one. What are the main challenges then facing decentralized storage adoption and scalability?
Right now, I think it's, in the first place, an ease of use. For instance, when it comes to storage, imagine how easy and quickly things would start changing if you had, I don't know, blockchain drive on your laptop that you can use and just store. In many cases, there are no good tools and convenient tools to interact with blockchain networks when it comes to mobile devices like phones. There are not so many on smartphones. So ease of use will be the first thing. From the enterprise storage point of view, maybe not ease of use, but more like lack of easily available gateways from current enterprise storage. For instance, a couple of years ago, when cloud storage started becoming popular, many enterprise storage vendors provided kind of stubs or plugins that would allow you to store some of the data quietly in synchronize with cloud. Why not do something similar with blockchain networks, storage networks, which would de facto become Cloud V2. And if you make part of that, part of the enterprise storage solutions, then many people would start using those without even knowing. And in many cases, many applications actually provide that, and consumers don't even know. So ease of use in the first place, yes, that would make things much more popular, and it would bring this notion of blockchain, storage, not just storage, blockchain services, closer to everyone, so that they could know that they can just use it.
And for the interest of time, Stephen, I mean, how do you see Web3 storage solutions address some of the key challenges faced in traditional centralized storage systems, such as scalability, security, and cost?
So, I mean, as I mentioned, because it's a permissionless network, right? Open marketplace, cost should be very efficient, definitely for the next couple of years, because you have a ton of providers that can now differentiate. Because what the public cloud vendors have done is they've sort of like reduced the margin of the managed service providers that initially had the relationships with the enterprise customers. And now I think, some of them are only making 8% margin. Now they can build tooling on a platform that is completely differentiating than a cloud provider can offer today. Of course, it's not equivalent, but with these smart contracts, you can provide more differentiation and control back. So I think that is that innovation that, that sort of like there's something in it for not just the user, but also the service providers in the field that around the world that are, building those and are that have those direct relationships with enterprise customers going to be crucial. So I think, yeah, and then to what Rafal's saying, making that usability, and build out all these features that enterprises are looking for, encryption and, compression and, control over how your data is being stored. That's going to happen initially through these gateways, very similar to when file systems were, or when object storage came out and, applications were still using file systems only. I think we're already seeing it today. We're seeing these on-ramps. So I think, in the near future, we're going to be seeing more of these applications running on sort of a hybrid stack where you have a gateway. It can be run by a service provider, right? That is then using decentralized storage from the backend. We're actually seeing that today already, and that's probably like that.
I think we need maybe 2-3 hours for this. We got a few moments left. We're going to go to Joe, who's going to ask some questions from the audience, and then Joe's going to wrap up the event. So Joe, I'm going to pass it off to you.
All right, absolutely. So we got one comment that's loving this. We definitely want more of human creativity rather than generative AI. So I thought that was a cute comment. No, there's no response to that one. That was just an audience comment. But we did have a couple of questions that are related. One, I believe we answered. So the question is this describing an Ethereum application with smart contracts? And I believe it's already been answered, but maybe just one sentence, Rafal and Stefaan, on that. Just like one sentence.
It could be, but the fact is that smart contracts are not limited to Ethereum these days anymore. So the way this works, Filecoin already implements smart contracts. So yeah, it could describe.
Yeah, so it's an analogy. It's analogous to those kind of smart contracts. It's sort of another approach in that space is the way I view it.
Mm-hmm. Yeah, I think Ethereum did a great job in sort of standardizing how smart contracts can be utilized. Like, there's different ERC standards.
Several ERCs,
built. And so what's happening now is if you look at Filecoin just came out with an EVM, a smart contract layer. In the first phase, the Filecoin implementation is completely based on Ethereum. Why? It's not going after the Ethereum audience, meaning it's not trying to be a replacement. It's trying to capture that audience that is already used to Solidity, developers that are already used to develop against an EVM compatible interface. So essentially, you could say that Ethereum is sort of like the S3, but for smart contracts, where Amazon started off with the first object interface or commercial version of that, and eventually became sort of the standard. I think that's what's happening now. And so, but the use cases are different, right? Because on decentralized storage stacks, you're looking at contracts, smart contracts that could maybe replace traditional databases, right? Where you would store normally, the relationship between data that's stored and the owner that's responsible for that's owning that data set, and other things. You can put value in a smart contract that pays for, let's say, a replication or extends a copy beyond a certain retention. So there's a lot of possibilities there that you can do now.
Yeah,
and the beauty of it is that you can just create a smart contract and deploy it and try it out.
Yeah,
no one limits you.
Yeah, and so zero knowledge proofs are an entire fascinating area of computation by themselves, and maybe we can organize a SNIA network storage forum on zero knowledge proofs, because you can see how not having to reveal details of what you have to prove that you have it is fascinating, and the way that actually works is extremely complicated, but it's proving invaluable in building the kind of architectures and systems that Rafal and Stefaan have been talking about. Now, if I switch gears a little bit, we had a question about service level agreements, SLAs, around guaranteed performance, accessing data stored in, say, a Filecoin or a Web 3.0 distributed storage. And I've had other discussions around performance as well. This isn't the only one. And people are saying, well, but I can't really get performance out of this. So what are you guys, again, quick response, because we've got about 2 minutes left. So this will be the very last question. Just 30 seconds each on how do you deal with performance?
Oh, go ahead, Stefan.
Performance is completely, it's completely storage provider based, meaning the storage provider decides what type of performance, the restore performance, they want to deliver to a customer, depending on how much the customer is willing to pay for it. So you're seeing different tiers being implemented. The Filecoin, specifically the Filecoin stack itself, currently is more of an archive tier, because the retrieval, to be very transparent, because of the ingest and the retrieval from a native sealed, as the Filecoin stack calls it, sealed copy, which is this highly secure format. Because why is it highly secure? Because we want to ensure, or the Filecoin protocol wants to ensure, that no one can cheat the system or create a data set that is not the original data set, and so it's extremely hard, and therefore it's also, the restore is slow, but the storage providers offer extra cache copies to facilitate a faster restore. And that's what we're seeing right now, is sort of like you walk into a customer, they're looking for a backup and archive, you store a full copy, you store a sealed copy onto the network, which is immutable, and then you can always recover from that. So we're seeing different tiers being implemented on top of the stack.
So what that tells me is there's a lot of interesting opportunities available in this space. All right, so with that, we're out of time. So we'll have to end the formal presentation, and we're back to the close-up. So please rate this webinar. Tell us what you think. Tell us if you want more in this area or adjacent areas. I find this extremely interesting, and hopefully you do as well. You can reach the content through the SNIA Education Library link or the SNIA SFS blog.org, where we'll post written answers to all of the questions, and you can follow us on Twitter. So thank you very much for your time. And with that, we are done with 30 seconds to spare.